So for your warm-up, you're going to be finishing your homework problem from last night that you copied off the board, all right? So then, if you did finish it because you took care of business yesterday, then you're going to compare your answers. So I'm going to give you like 2 minutes to either finish it up or compare your answers. All right. Go. Compare your answers. Alrighty. Okay, I hope you are as excited about today's lesson as I am, because I'm ready to turn it up. Are you kidding me right now? Okay. All right. Let's go ahead. We're going to go over our homework answers, okay? So this is where your homework came from. It's this little page that I gave you. Also, this should say H and not a second F. So, ooh, yeah, look, that looks pretty. Thank you. Thank you. So encouraging. Okay, so we're going to find f of x when the following is true. Now, if you notice, the direction actually said write your answer as a point. Well, we didn't do that yesterday in class, but how do we write answers as points? What we plug in is our what coordinate? What we get out is our y coordinate, okay? All right, so -2. Where should -2 be plugged into? Which equation? First, second, or third? The first, because -2 is in between what? -3 and 0. So if I plug in -2 for x, I'm going to get out what? Okay, so -6. That's your y coordinate. So your point is -2, -6. All right, for 0, first, second, or third? Heard somebody say first. Heard somebody say second. What made you think second? Very good. If your 0 shows up twice, everyone listen. If your 0 shows up twice in your problem, you use the one that has the line underneath it, because that means it can equal 0. It's included. You got it? So if it shows up twice, you use that one. If it doesn't show up, then that means it's probably going to be in your range somewhere. All right? Or the domain, I really should say. Okay, so my 0 is the second one. What's -0? 0. So what's my point? Okay, -1. First, second, or third? First. And if you plug in -1 here, what are you going to get out? -3. So what is your point? Beautiful. All right. 1. Where'd you plug that into? First, second, or third? third. But when we look at our third equation, is there a variable that we can plug in x into? No, so it's just 4. So my point is 1, 4. All right, for E, number 5, where would you plug in 5 at? The third, can you plug in 5 into this variable? No, so it's just 4. So 5, 4. All right, 0.3. Ooh, I'm trying to trick you with decimals. Where would 0.3 go? First, second, or third equation? Second, because 0.3 is in between 0 and 1. So what would that be if you plugged it in for this? Very good. Negative 0.3. So what's my point then? 0, negative 0.3. All right. Letter G. 1.11. Ooh. Why the third? Because it's greater than 1. So if I go to plug it in, there is no variable, so it's just 4. So you would have 1.11 comma 4. Sorry, I forgot the 0.3 up top. Right, y'all. Okay, letter H. Give an example of a number that is not included in the domain. Meaning, if they gave you this problem, if they gave you this number, what kind of number would not fit anywhere into any equation? It wouldn't have anywhere to go. It would be homeless. All right, so let's see. Damon, what'd you say? Damon said negative 4. What'd you say, Cameron? Negative 5. Are those both homeless? Yep. Bubba, what'd you say? You said negative 5 too. Anybody say anything different? Anyone? What about negative 100? Yeah, that wouldn't be included either. What numbers could we say in general would not be included?
Any negative number.
Very good. Any number smaller than negative 3. Question, could negative 3 even be included in our problem? No, why not? Because there's no line under it. So it's actually any number that's negative 3 or smaller. You got it? So you could have put negative 100, you could have put negative 5, you could have put negative 4, you could even have put negative 3, or whatever you wanted. Okay? No, you can put negative 3. It's still not included in the domain. Negative 3 is not included. These are all the numbers not included. Okay, any questions about that? Okay, now I'm going to pass out a worksheet to you. And whenever I give you the worksheet, I want you to find the side that has this handwritten stuff on it. So let me go ahead and pass it out. Okay, what I'm going to go ahead and do now is I'm going to give you about 5 minutes to answer all of these questions. This is just like what we did for homework, all right? You're just figuring out where it would go. Before we do it, though, before you start, I want you to notice something. What word do they have in this problem? They have the word for. So you could actually have the word if or the word for. It means the same thing. Another thing that sometimes books like to do is they like to put commas after the equations. So it's just all in how they decide to write it. But you know it's a piecewise as long as there's more than one thing, but they should always have at least one set of brackets around it. All right, so I'm going to go ahead and I'm going to give you 5 minutes so you can go ahead and get started now. When you are done, compare your answers with a friend. 2 minutes and 30 seconds remaining. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alrighty. Let's go ahead and look and see what our answers were. So for F, well, first off, before we talk about it, but I'm sure you figured it out. Anytime you see F of -6, what does that actually mean that you're doing in your own words? What does that mean you do? You're plugging what? Very good. You're plugging -6 into f of x. So it still means x equals, right? So whenever it's in the parentheses, that's always our x coordinate. That's what we're putting in. It's our input. All right, so -6. I want you to go ahead and hold up your hands. Hold up one finger for first equation, 2 fingers for second equation, 3 finger for third equation. So where did you think this went? First, second, or third? All right, very good. The first equation. And whenever you plug in -6 plus 1, what do you get? So bam, that's your first answer. Easy breezy. All right, -4. Hold up your hands. First, second, or third equation for -4. Very good. Why is it the second equation and not the first? Very good, because it has a line underneath it. It's equal to. But, oh my goodness, when I go to plug it in, I don't have a variable. So what do I do? You just put the number 2. Okay, someone just asked, can they ever be into more than one equation? No, never. All right, so my 0. First, second, or third? Hold up your hands. First, second, or third? Very good. Third. And whenever I plug it in, what do I get out? Because 0 squared is 0. Okay, f of 3. What do I plug in? First, second, or third? Third. And what do you get out? 9. Beautiful. F of 1. First, second, or third? Good. Third equation. And what do you get out? 1. F of -2. First, second, or third? Second. Beautiful. And what's our answer just then? 2. Plain old 2. All right. F of 10. First, second, or third? Third, and what do you get out? Negative 20. First, second, or third? First, and what do you get out? Negative 19. Now, I'm going to ask you a question I don't want anyone to answer out loud. No one answer out loud yet. I just want you to think about it, okay? And don't shake your head yes or no either. Don't give it away. Just keep your thought in your head. Is there any number that would not be included in this problem? Is there any number that would not be included in this domain? Look right here. Can I ask you for any number, like negative 1,000 or a million? Would any number not have an answer? If you think you know your answer, raise your hand. All right, Miss Braley, what do you think? Very good. Braley said that any number can be put into the problem. Why, Braley? Oh, beautiful. I'm going to repeat exactly what you said so our friends in 6th hour can hear. Braley said that no matter how small the number is, it could still be in the first one. And no matter how big the number is, it could still be in the third one. Good job. Everybody get some snaps to Braley. Whoop, whoop. Yeah, good. Okay. Or claps. Doesn't matter. Yeah, I would. Okay. Let's go ahead and look at the bottom part now. I love this. Ooh. Now, this is actually review, my friends. This is not just piecewise functions, but it is a picture of a piecewise function. Who remembers from earlier this year how we find g of 2 if we're looking at a graph? Isaiah, what do we do? Very good. You find the x where it's 2, and then what are you looking for? The y coordinate. Good job, Miguez and Dylan Cormier. All right, so I'm going to figure out where my 2, right? So where's 2 at? Positive 2, and then what's the y coordinate? Negative 2. All right, let's go ahead and do g of negative 3. So g of negative 3, so I find negative 3 on my x. What is the matching y coordinate? Bam, easy. And then I wanted to throw in a rate of change problem. But before we do the rate of change, let's talk about these open circles. 1 second. Ask me your question in a second. Let me pause the video. Okay, what I want to bring your attention to are these open circles. Technically, in algebra, if we have an open circle, our function is undefined at this point. This is called a hole in the graph, all right? So in Algebra 1, if we're looking at this and we're asking ourselves, what is the value, let's say, of g of 0? What is the value of g of 0? Well, you might think, well, there's 2, because I have this point and I have this point. In Algebra 1, we only recognize the point that is not an open circle. We don't recognize the holes in Algebra 1. When would you start to? Well, if you take calculus, then you're recognizing it as what the function is intending to go. It's the intended y coordinate of it, okay? But in Algebra 1, we don't recognize it. We just say it's undefined there. You got it? Okay, so g of 0 would actually just be this point right here because it's not an open circle. Y'all see that? Do you see another point on this graph that is going to have the same case scenario? When x equals what? Yeah, g of 4 would be the same because here I have an open circle and here I don't. So what would be my answer in Algebra 1 for g of 4? Yeah, just the negative 2. It's not the open circle. Everybody got that? Okay, so knowing that, let's go ahead and do the rate of change problem. You have seen this definitely on your warm-up and definitely on your practice EOCs. How do I find the rate of change in an interval? What do I have to do? Good, you find your 2 points and then you subtract your y's over your x's. Okay, but this time, do I have an equation to plug in? No, I'm just figuring out what is the y coordinate based off of this graph, okay? So when my x is negative 2, that's my first point, correct? I got to figure out the y. So when x is negative 2, what is my y? 2. And then here, when x is 0, what y am I going to recognize? Just the one that's not an open circle. Y'all got that? So it would be 0. And then from there, how do I find the rate of change? Subtract your... So, does it matter which order we go in? No, as long as we stick with the same one. So what's 2 minus 0? Over, what's negative 2 minus 0? What does that reduce to? Negative 1. Bam, that's your rate of change. Okay, and then I wanted to throw this in there, y-intercepts. What is a y-intercept? Where it crosses the y-axis. All right, so technically, well not technically, but just by looking at the graph, how many y-intercepts do you think it would have, just by looking at it? You'd probably think 2, because you have this point and this point. But what's the only point that we recognize for Algebra 1? The one that's not open circle. So where's my only y-intercept at? 0. Now here's something interesting. I use the term zeros down here. What does zeros mean? Where it crosses the x-axis. We saw that when we looked at parabolas, right? What are the zeros of the function? So it's just the x-intercepts. Beautiful, Cameron. Okay, so where am I? Well, at first glance, how many x-intercepts does it look like I have? Looks like I have 2, but in Algebra 1, do we recognize open circles? So what is my only x-intercept then, really? 0. Very good. Okay, the max. Max like a maximum. Where else have we heard that word before? In our quadratic. But guess what? Just like for a parabola, we said the maximum was the highest point and the minimum was the lowest point. You can still ask that for any kind of graph. So for this piecewise function, what is the maximum point it will go up to? Y infinity. Because it has arrows. So that means it's never going to reach a highest point, right? So for the max, I'm just going to say it's infinity. Continues to get higher and higher. Remember, max is short for maximum. Okay, for min, which is short for minimum. For min, what is the lowest point this graph will go? Okay, so some people are saying 0 because you don't recognize open circles. But what about all of these? Are these considered open circles? Exactly. Very good, Alex. These are not considered open circles. So your minimum point would be negative 2. All right? You should feel like a boss for being able to answer all of those. All right? Any questions about this? Now we're going to go to the best part of piecewise functions, and we're going to practice graphing them. Because you will get this right for your bonus question. Whoop, whoop. Yeah, you know you love it. All right, that's right. Okay. Let's go ahead and look at part A. Yesterday we kind of looked at some of these before, but I'm just going to look at these a little bit more in depth. What I want you to do first, before you even graph this, I want you to label, would it be an open circle or a closed circle? So this guy right here, since there's no line underneath it, we talked about that yesterday, is it open or closed? Open, and I'm just going to make a note about it, open. All right, what about for the second equation? And what makes that closed? Very good. Okay, now the other thing, they just gave me a grid. They didn't give me an XY. So I'm just going to draw, I'm just like kind of halfway. My lines aren't going to be very straight. It doesn't have to be exactly like mine. Just eyeball it. Okay, everybody got it drawn? All right, cool. Now, yesterday we talked about whenever we're graphing our piecewise functions, we always use our domain restrictions. You got it? Okay, so for this one we're going to start with the number 1. So if I plug in the number 1 into this equation, what's that going to give me? What's negative 2 times 1? Plus 3? 1. So I have the point 1, 1, and I'm going to do an open circle at 1, 1. Now, whenever I just have 1 point, that's not my answer, because this right here says x is everything less than 1. So that means I either have a line going this way, this way, this way, this way, just wherever. We got to figure out where it goes. The best way to do this is to pick a number that is less than 1, and you want to pick the one right next to it. So what's a number right next to 1? 0. So plug in 0. What's negative 2 times 0? Plus 3. So your point would be what then? 0, 3. But listen, you are not going to graph this point with a big open circle. This point is just a tiny little dot that tells you where your arrow goes. So at 0, 3, look how small. Boop. My tiny little dot. You can't even see it. All I did was boop. And then I'm just going to connect this with an arrow. Y'all got it? Okay, so now what do I need to do for my next equation? Graph what point first? The 1. And when I put 1 in, what am I going to get out? What's 3 times 1? Minus 4. So 1, negative 1. Open or close? So 1, negative 1, and it should be closed. I can't just have a point, so we got to figure out where do our dots go, right? So right here, do I want bigger or less than? Bigger. So what's a number bigger? 2. So what's 3 times 2? 6 minus 4. So 2, 2. Oh wait, 2 2's up here. Ooh, special. And make a little bitty dot, bloop, and then just draw your line. Beautiful. You have just graphed a piecewise function. Yes! Alright. You know you're excited. Don't worry about that. Okay, part B. What do we need to do first? Let's go ahead and label open or close. Open, and then close. Now, you see how right here I have the number 9? I'm going to be smart, and whenever I go to draw my grid, I'm not going to draw it in the middle. You need to draw your grid like to the side. That way you have enough room for your 9. And before we get started, I want to tell, because some people still get confused with a less than, greater than. We talked about less than makes an L, but here's another way you can look at it. If the inequality sign is eating the number, it's less than. If it's eating the X, then it's greater than. That's just a little shortcut. Now that rule only applies as long as the variable is the first thing you see, but for piecewise functions it should be. Okay? All right. So let's go ahead. What am I going to start off plugging in first then? 9. So 9, 1. Very good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Open or closed? Open. Now I can't just have a dot just hanging out there. So what do I need to do? Okay, now why would I pick the number 8? Because you're going to get one smaller than. Does everybody understand? And I know I wanted less than because it makes an L, or it eats the 9. All right? Okay, so if I plug in 8, what would I get out? 8, 0. Now when I make this dot, is this just a little bitty dot, or is this a big dot? It's a little, it's bloop. All right, so I go to 8, 0, bloop. 8, 0, because we plugged in 8 and we got out 0. Be kind to one another. Everybody makes mistakes. All right. So now, my friends, what do I do with this number 9? I'm plugging it in. Okay, now, some people see this and they're like, oh my gosh, it's a fraction. But not people from Midland. Here's why. Because we are bosses when it comes at fractions, all right? So look, if I'm plugging in 9, I would have 1/3, put 9 over 1, minus 2. And how do I multiply fractions? That's no problem. Tops times tops and bottoms times bottoms. So what is 1 times 9 over 3, which is 3, minus 2 is, so what is my point? 9, positive 1. 3 minus 2 is 1. So 9, 1. Now open or close. What do you notice happens? It's the same point. And that's okay that it's the same point. Okay, now we need to pick another number because I can't just have it chilling there. So here's the deal. Some people might say 10, but let me give you a little fraction tip. If you want it to be a whole number and not a fraction, you need to pick a number that would be a multiple of this 3. So somebody said 18, somebody said 12, somebody said 24. 12 is what we're going to go with because it is the closest. So 1/3 times 12 over 1 minus 2. What's that going to reduce to? 12 over 3 is 4 minus 2 is 2. Okay, if I don't have enough spots for 12, just kind of put it where you think it would be. So this would be 9, 10, 11, 12. I'll do at the very end. And 12 what? 2. And just a little beep. And you connect it. Okay, let's go ahead and ask some review questions real quick about this. Is this a linear graph? No. Why is it not linear? Because it's a straight line. Now let me ask you one other thing, and this question is going to kick it up, separate the men from the boys, the women from the girls. If it is nonlinear, what does that imply about its slope? Beautiful. Beautiful, Ben. It's not constant. It's only a linear line if it's constantly changing at the same rate. So like look right here. You can see I'm going up 1 over 1, up 1 over 1, right? Am I still doing that here? No. Now I move to up 1 to the right 3 is what it really should look like. So if it's not linear, that means it's not a constant slope. Now here's free knowledge. You're welcome for this. Free knowledge. Think about a parabola. Is that going to have a constant slope? No. Why not? Because it's not linear. Calculus will teach you how to find slopes of parabolas. Just letting you know. All right, let's go ahead and look at problem C. This is the last one we'll do together because you're doing D solo. All right. No, you're doing D in class. All right, so let's do C right now. We're going to go ahead and label. What's this guy going to be right here? Open. What about this guy? Close. What about this one? Open. Let me write out close so it doesn't look weird. And then what about this one? Close, because it has a line underneath it. Okay, I'm going to go ahead. I'm going to separate my grid. I'm going to do halfway. Yeah. I told you I'm not perfect. My line is just the best that I can do. That's all I can be is the best I can be. That's awesome. Okay, so what do I need to do with that -2? Come on. I'm going to plug it in. And what do you get out? -2, -6. 1, 2, 3, 4, 5, 6. Open or closed? Open. Bam. My other dot is not going to be a big dot. It's just a bloop kind of dot so I can see where it goes. So, do I want a number less than -2 or greater than -2? Less than. What's the number less than? -3. So, what's -3 minus 4? Now, oh my goodness, we don't have it on here. That's okay. Just put a dot of where it should be and draw your line. No big deal. It's a -3, like -7. Yeah, I just kind of guesstimated. Okay, now, what is different about this second problem we're about to graph? It has 2. So guess what? The 2, I think, are the easiest. You don't pick an extra point. When it has 2, you just use the 2 that they give you, and you make a line segment out of them. So our first one, I'm going to plug in -2. When I plug in -2, what do I get out? So -2, 1, closed. And then what am I going to plug in? 1. And if I plug in 1, I get out 1, 2, 3, 4. Open or closed? Wrong. Open, because there's no line underneath it. And then just connect the 2. How easy is that? I'm going to repeat it one more time what we did. That way you don't get confused. We find this point, and we got -2, 1. We find this point, and we get 1, 4. And it's open because there's no line under it. And you just connect the 2. So when there's 2 of them, you're just making a segment. You got it? Okay, so this one, where am I going to start at? At 1. If I plug it in, what do I get out? And so -1 plus 1 is 0. And it's closed. Now for this problem, do I have a segment or do I need to do a bloop? Very good. We do a bloop. So, do I want a number bigger than 1 or less than 1? So let's pick the number, what? 2. So -2 plus 1 is -1. So 1, I'm sorry, not 1. 2, -1. And bam. Okay, now, beautiful. I'm sorry, what? I chose the number 2 because I needed a number greater than 1. Now, let's talk about this real quick. I want to tie this back in before I give you a problem to do by yourself. For your homework last night, we mainly just focused on what would happen if x equaled 0, and we just looked at the equation. I want to show you how it ties in from the equation to the graph. So let's go back to what we would do for our homework. If I said if x equals 0, what equation would you plug it into? First, second, or third? The second. How come? Because it's in between -2 and 1, right? If I plug in 0, what do I get out? 3. So I would have the point 0, 3. Is the point 0, 3 on my graph? What? So all we were doing last night is just finding points on our piecewise function graph. You got it? So on the EOC, they could either, and what they'll probably give you, if I had to guess, they would give you an equation and say, what would it be if x is that? And you would just do it from there. But now you should be able to also look at a graph and do the same thing. But it all ties in together. You got it? Any questions about that? Okay, I'm going to give you 5 minutes again. I want you to graph letter D by yourself. When you are done, you can check your answer with your neighbor next to you. You have 5 minutes. Ready, go. All right, come to a stopping point. I'm going to go over this again. Since some people are still struggling, we're going to go over this one together, and I'm going to give you one more. All right? Okay, so let's talk about this one. You have 3 pieces to your piecewise function again. This tells you where you start, and we want to go ahead and label open or close. So what would this one be? Open. This one is close. Open, and then this one is close. All right, I'm going to go ahead and break my graph up. Just do it like that. Call it a day. All right, now, what you need to do, everybody listen, especially if you were lost. You have to start with this first number. If there's only one number, that means you're going to have an arrow in the problem. If there's 2 numbers, it means it's a segment, and you just connect both dots, all right? So 1 number means we have a bloop in our problem. 2 numbers means we find them and draw a line connecting them. All right, so for this one, we only have 1 number, so I'm going to start off by doing that. If I put 0 into this problem, what do I get out? Just -3, right? There's nowhere I can put 0. So my first point is 0, -3. So 0, 1, 2, 3. -3. And it is open because of what we put at the beginning. Got it? Now, I cannot just have a dot. I have to find my second dot. So I'm going to pick the number. What number should I pick? Should I pick the number 1? Why do I need to pick the number -1? Because it's less than. So if I pick the number -1, what will I get out? So just plot this point now. -1, -3. What do you notice? And look, when I plot it, it's just a bloop. What do you notice about this? It's a straight line. That's your first piece of your problem. Raise your hand if you understand that. Okay, second piece of the problem. How many numbers do I have here? When I have 2, that means I plug them both in and just draw a line. That's it. So if I put 0 in, what am I going to get out? I'll do this piece in red. If I do 0, I'm going to get out 2. All right, so 0, 2. Open or closed? And then what's my other number I need to put in? 3. So when I put in 3, you would get 3.5. Now, how do we get 3.5? 3 times 1/2 is 1.5. 1.5 plus 2 is 3.5. All right? If you're confused with this, you could use a calculator. You always want to change fractions to decimals when you're graphing. So 3 and 3.5, which would mean it would be halfway right here, and it's open. And then you just draw a line connecting it. And I'm going to do the last one in pink. So what number do I need to start off with? 3. So when I plug in 3, what am I going to get out? 5, right? Because 3 times 3 is 9, minus 4 is 5. You got it? So I have the point 3, 5. 1, 2, 3, 4, 5. And it's closed. But I can't just have 1 dot. I got to figure out where do my other dots go. So what would it be then? I would plug in a number greater than 3. And if I plug in the number greater than 3, what are you going to have? So let's pick a number 4. And then someone said 8. Is this going to be a big dot or just a bloop? All right, so 4, 1, 2, 3, 4, 8. 1, 2, 3, 4, 5, 6, 7. Where would 8 be? Right above it. Just bloop. Notice my bloop. You see how small it is? You shouldn't even see it once your line goes through it. Oh, sorry. There we go. Oh, whatever. Okay. This is my piecewise function. Raise your hand if you understand this better now. Let me recap one more time what we need to do. You start off by listing if it's open or closed. You got it? If there's only one number, you do that one, and then you have to find your next number. You got it? And how do we find our next number? We plug it in. How do I know what number to plug in? Come on, everybody, focus. How do I know what number to plug in? The sign. Thank you. And this tells me less than, so I'll go less. Yes or no? All right, I'm fixing to call somebody up here to come and explain how to do this problem because hardly anyone's listening. I want it in your own words. Raise your hand if you want to volunteer for that. Okay, I will pick somebody else then to come up. No one wants to volunteer? Yeah, to explain how we graph this in your own words because some people are still looking like they're confused. All right, let's see. Miss Basco, come on up. You can do it. If you had to teach it, what would you say?
Open or closed,
Okay.
and then plot my 2 points after I figured out what they were.
Okay, good. Decide if it's open or closed. Plot her 2 points after she figured out what they were. Would anybody like to add on to that? Great. Mr. A-Bear. Coming at add on to that. She just said plot the 2 points that they know. What do you know about, how would you tell if they were open or closed points?
You tell by the lines underneath. Oh, you tell by the lines underneath the greater than or less than sign.
Okay, now how do I know if I need to find an extra point or if I'm good with my 2 points?
If you have 2 points, then it's got a line, and if you only have one, you boop.
Very good. Raise your hand if you understand this. Okay, for the last 5 minutes of class, I'm going to give you a problem that I want you to work by yourself. And I'm just going to make it up, so I'm not really sure what it's going to look like. No, it's going to come out to the correct answer. It's just going to be, might look a little special. All right, I'm just going to give you 2 equations. All right, you're going to graph it, and this is your homework tonight. So just write it down, and you can get started. It's the only problem that you have to do. When you are done, you can pack up because the bell's going to ring in like 4 minutes. Oop, I just looked. I noticed one mistake. Put this like that. Yeah, take the line off of that 0. I mean, we could have still worked it, but it wouldn't have really been a true piecewise function.